It is my really great pleasure to introduce the three instructors in this course. Angela, from Germany originally, but at Toronto now. Angela heads the Dynamic Systems Lab at the Institute for Aerospace Studies at the University of Toronto. And she's also the Associate Director of the Center for Air Robotics Research and Education. I had to cheat, because your title is longer than any other title I've seen in my life. So what does that mean? What do you do?
So I'm leading a team conducting research at the interface of robotics, controls and machine learning. And what this means is we build robotic systems that can learn from experience and from each other. And the goal is that they, through that, can do tasks better, operate more safely, and are generally more independent.
That's exciting, because you have like 10,000 Amazon drones in the sky. If this one learns something about the world, all the 9,999 others will learn the same thing.
That would be one of the ideas, yeah.
That's great. Nick Roy, we've known each other for a long time because we worked together at Carnegie Mellon University, but he's now professor of aeronautics and astronautics at MIT and leads a group of researchers in CSAIL, MIT's artificial intelligence lab. What do you do?
Well, to first order, I'm very lucky to have a great group of students and postdocs, and I do PR and fundraising for them. But more specifically, what we do is we look at a lot of related issues to what Angela was mentioning, issues of vehicles, how they navigate in complicated, cluttered environments when you don't have external infrastructure like GPS, et cetera. We look at the issues of how these vehicles understand what's happening around them, especially in a human-centered environment. They need to be able to interpret what's happening around them, understand what people want, and make safe and reliable decisions.
Now, together we're building the Nanodegree program on flying cars. And flying cars is a bit of a misnomer. It's not going to look like cars, not going to have bumpers. But the field of flying vehicles has become incredibly hot in Silicon Valley and around the world. And I'm super delighted we could attract two super stellar professors to teach this and build this program with us. I want to start with you, Angela. Tell us about how did you get involved in flying machines and cooperative flying machines?
My background was math. I did a lot of control theory and theory improving, and I wanted to see this in action. And flying vehicles were just the first thing that came up in 2008. So that's how I started working with robotics.
And Nick, you started working on nursing home robots before you did anything flight. How did it happen for you?
Well, so after I got my job offer at MIT, I went home to visit my parents with my wife, and you go into your bedroom where your parents have kept all the things that you had when you were growing up, and Christine noticed it was just rows and rows of books about airplanes. And the thing is that when I was a little kid, I just loved airplanes and aircraft, and I used to, when we'd get stuck in traffic in Vancouver, I'd bug my mother about, like, we should really own a helicopter. And so, massively impractical, from a suggestion from a 6-year-old, but the thing is that there's just something that's always been super appealing to me about 3D motion, flying through the air, flying like birds. And then after I finished my PhD at Carnegie Mellon, I had the opportunity to come to MIT and take a lot of the technologies that we've been developing for ground vehicles and put them in the air. And it's just, it was like coming back to the thing that I had loved for so long when I was a kid that got me back into this.
So you're going to have a helicopter soon?
Me personally?
Yes.
Well, sad to say, I am both mechanically very non-dexterous, and the complexity of flying these things is not something that I personally am good at. But I get to work on the technologies that make like a dummy like me who can't really fly these things actually able to make them work.
Well, so our Nanodegree program really teaches you, our students, all the different components to build drones, to build cooperative drones, to build flying vehicles, a bit bigger ones that you can sit on, like drones you can sit on and so on. But one of the things that's really remarkable is that this field has become incredibly hot in the last 2 or 3 years, I would say. Why?
Well, so there's been two, I think, big tectonic shifts. One is that through a variety of forces, market forces, technology forces, all of a sudden the components are there to make very small drones are a lot easier for ordinary people to use. So just like the cell phone industry, in one sense, has given us the necessary technologies in terms of batteries and computers and electronics, et cetera. And the other is a major regulatory shift in that the FAA has been surprisingly active and progressive in opening up the space for these kinds of technologies. So the confluence of those two things together has produced this remarkable flourishing community of enthusiasts.
And you live in Canada, so it's not FAA, it's a different regulatory body, but
Right.
What's the situation there?
So it's called Transport Canada in Canada, and for a while Transport Canada was more progressive than in the US. So companies like Amazon would come to Canada to test. They have been really supportive in general for the research. We have a conversation and usually they make it work for us. So I think they will support whatever we develop as long as we can prove that it's reasonably safe.
So Jeff Bezos from Amazon was probably the first to make this very public topic, and of course Google, thanks to Nick, who actually founded and ran the Google Wing team, which is the Google drone team, it's become a topic of mainstream, like this idea that the sky is covered with drones that bring you Amazon packages and what have you, or even people in the case of Kitty Hawk. How real is this? Is this something we should think about today?
I think we should think about this today. There's still quite a bit of work to be done, but as researchers, we have been working on the controls and safety aspects for a long time, and also incorporating machine learning to improve safety.
Yeah. Do you think it's going to happen soon?
Well, in some sense, it's already happening. That little drones are being used to do things like take pictures of people's houses for real estate, do infrastructure inspection. When I was living here in a couple of years ago, as you said, founding Project Wing, I would drive my son to school, and we would drive across the Dumbarton Bridge, and there's a series of power lines, and we would see a human being hanging from a giant helicopter. I mean, giant relative to little drones, a normal size helicopter before drones existed, and that person hanging from the helicopter would travel along the power line inspecting. You no longer need to do that. So in some sense, the promise of, this is a massively dangerous thing. I hope those people were paid a lot, and that you no longer need to do that. So in that sense, drones are here. You can do things with them. The question is the sky full of drones? Clearly not. We can look outside and you don't walk out and see drones up there the way you see cars down the street. So there's more work to be done, as Angela said. There's issues of reliability and safety and so on that still need to be solved to really scale up.
Great. Tell us the tale of the Project Wing. What happened?
So Project Wing was started with your help and with Sergey and Astro's help. The vision was to build vehicles that could deliver anything to anybody, anywhere, anytime. And I think that's still a great vision.
Yeah, and you did this amazing thing in Australia where you actually were able to fly a package to a farmer, one of the very first ones ever, and then wheeled it down. Tell us about it.
Well, so that particular activity was kind of fun in the sense that we were doing prototype testing, but involving real people, and the farmer, Neil, said, you know what, my dog is super excited. Do you think those are something for the dog? And so we kind of took our first order that day when he, one of the team members radioed and said, let's deliver dog bones, and we happen to have them. So that was just kind of fun. What we saw is that people, certainly in Australia, but around the world, were really ready for this. A lot of the things that we thought might be said in a negative way about it generally weren't said, and I think it's a question of just maturing the technology, figuring out a lot of the issues with reliability, scaling it up, that it's going to be very compelling.
And do you think these things will be safe in the future? Or will they fall from the sky and kill people?
No, I do think it's safe. It can be safe. We see it with airplanes. Airplanes are incredibly safe. So I think we just need the technology, certain redundancy to make this happen.
Tell me about airspace management. I mean, if I look at the number of Amazon packages I get every day, it's about 3. And all my neighbors are 3, so it's going to be in my neighborhood maybe 30,000 packages. If they got all delivered by air, how do we manage the airspace?
Yeah, this is a good question. I'm not sure if it is solved. There are ideas around that each drone, when it takes off, reserves a certain space that it needs for the next little while. This would be a distributed system, so every drone reserves space when it's needed. Distributed is never as good as a centralized system. So I think we will see which method will win.
So we come here together because we are building this joint nanodegree. It's the world's first educational program on flying cars, and hopefully in a good Udacity fashion we will teach more students these technologies than all universities in the world combined. Let's find out. But I want to ask both of you a bit about what you're actually teaching and what the interesting problems are for students. Maybe start with Nick.
Yeah, okay.
So for me, the flying car is a great aspirational goal. We've got a long way to go. The real content that I want students to get from this is addressing the challenges of making these vehicles smarter. So one of the dirty little secrets of any unmanned system, whether it's on the air or on the ground, is the total labor, human labor required to operate that unmanned system. These vehicles are fundamentally really dumb. All they do is get from point A to point B. They can't react to the unexpected in the ways that people can. They can't adjust what they're doing. That kind of intelligence, that kind of reasoning, that kind of autonomy is core to what we're trying to teach for enabling flying cars.
Great.
So what I'm really excited about in this nano degree is that we really teach the fundamentals on how the physics of these vehicles work, both fixed wing and multi-rotor, but then take it all the way to a real implementation, either in a high fidelity simulator or on the real drone itself. And I think both skills really are needed to bring the field forward in the future.
The fact that these are flying vehicles really forces you to deal with the physics. Even something as simple as how do you represent the attitude of the vehicle is very different and much more complicated in 3 dimensions than it is in 2, and that's core to what we're doing.
That's fantastic. So who should sign up for the nanodegree?
Everybody.
What are the prerequisites?
Well, so you because of the physics, you're going to have a basic competence in math, and you're going to have basic competence in programming.
And probabilities.
Probability, yeah. The uncertainty of the real world is key.
Yeah.
So when you worked in industry, in particular at Google X, and hired people, what's your general assessment? Is this like AirAstro people don't talk to computer scientists today, or is there people in the middle?
Well, that is probably the common case, which is that AirAstro engineers and computer scientists have a very different view of things. Computer scientists are used to the idea of rapid iteration and trying things until they break and then fix it. When things break in midair, bad things tend to happen, and AirAstro engineers are very aware of that, and they're very responsible about dealing with the failures. What I think we are seeing is a convergence of those two as AirAstro engineering becomes more receptive to the idea of iteration, and also computation is core to everything that we do now. And computer scientists are becoming, frankly, more responsible and not deploying things that are just not ready. And we see that at every level. We see computer scientists and air engineers so residential universities like MIT taking classes together. We see graduate students, becoming very similar. And it's no longer the case that you had to hire a control engineer to prototype the system and then a computer scientist to implement the reliable thing. One person now has enough skills to do both of those things.
And I hope that this program will actually contribute to this.
I would love for that to be true.
There's a massively growing industry. I think we are in the field of flight in general, drones or flying car is a bit of a misnomer, I think. We see the same activity and promise that I would see in self-driving cars maybe 5-6 years ago, when only Google and a few small other teams were working on it. And now self-driving cars has become the biggest topic on the planet. And I could imagine that the flying car or the flying drone could actually disrupt the self-driving car. And the reason why I believe this is because the air is much more ample than the ground. So I actually do believe that safety in the air will be higher than safety on the ground because there's fewer things to hit. Right. So as long as we don't fall from the sky and fall subject to gravity, we should be able to be safer than on the ground. That's my objective for this field as a whole.
It's pretty clear that the transportation industry as a whole is going to look very different 30 years from now. And I agree that flying cars are going to disrupt transportation on the ground. It won't eliminate it, but it will make it look very different.
Yeah.
I'm not sure that I'm ready or will ever be ready for my sofa to be delivered by a drone. Maybe, but
maybe by a blimp.
Maybe by a blimp, but there's going to be a role for all these different technologies, and they're going to be complementary, and that's what that's going to look like.
I actually believe that you could disrupt freight with flying vehicles. If you look at the math, because the amount of energy, if you want to go fast, the amount of energy dispensed for lift is relatively small compared to drag.
Are you arguing for all of ground transport going away?
So I think these disruptions it's very hard to predict, but they're very nonlinear. Like if you look at a picture of New York City from 1900s, you see lots of horses and an occasional car. You go fast forward 30 years, and the city is full of cars and the occasional horse. And I don't think if you had asked people in 1900 and looked at the car and said, is this thing going to take over all the horses? I think every person would say, no, absolutely no way, right? And it took 30 years. In the modern age, it now goes faster. Maybe it takes 20 years. I could imagine, I mean, if I look at my current traffic situation, if I had a safe way to go from my home to my work in 5 minutes to the air, I would just prefer this every single day over my 30-minute commute on the ground.
Sure. But we, just in the same way, you could have said, well, our car is going to disrupt all of trains. Cars disrupted trains for sure, but they didn't eliminate them.
Correct.
And so I think there'll be like a mix of these different technologies.
So I want to drill a bit more into the issue of safety. And the reason is we are marrying machine learning, where we can't typically know what the outcome is, with something that if the outcome is wrong, might fall on our head, or even worse, might have a person fall from the sky. Angela, you're an expert and you're super excited about this. Tell us about this.
Right. Yeah, I'm super excited to use machine learning to enhance the capabilities of flying vehicles and standard control systems. And we have found ways, either by having the correct software architecture or good underlying statistical machine learning techniques, to still guarantee safety. So we could allow a flying vehicle to adapt to a passenger's weight or preferences while guaranteeing that it stays safe in the air.
And how does this affect the machine learning? I mean, if I look at machine learning today, there's all these ones with deep learning, and it can detect cancer or replace lawyers, but there's no clear rules like what safety means in those fields. How can you guarantee safety in this situation?
So guaranteeing safety may mean guaranteeing stability, and what the resulting machine learning algorithms may be more careful and learn slower, but adapt in a way that guarantees that I always can come to back to a safe condition if something goes wrong.
So one of the things that I myself worry about is how are we going to get to these models of reliability. We take conventional engineering, which generally means that you have a very clear mathematical model of how the thing's supposed to work, and you can understand it. Self-driving cars largely are just verified on the basis of lots and lots and millions of miles of testing. Those things are not the same. Do you have any sense of how this is going to boil out?
You mean in terms of how we can guarantee safety?
Yeah, are we going to have like clear models that describe how the thing's supposed to work that we can formally verify or inspect, versus just, yeah, it worked a million times, it's probably going to work the millionth time?
Yeah. So how I view it is that we have not a model but a set of models. So that could approximate all different payloads that a flying car needs to carry. And then as we go in the air, we have a controller that guarantees safety for all those possible models. And then as we gather more data, we get more information about the specific situation that we have right now.
And so in Kitty Hawk, where you must be faced with the same problems, how are you planning to verify or otherwise test or certificate your systems?
We're working right now with authorities on certification. And certification in the airspace industry is a 5 to 10 year effort, where you really have to characterize individual components and make the case that if the vehicle is used as intended, that the probability of failure, catastrophic failure, is low. What aids us is that electric motors fail much less frequent than regular combustion motors. Like if you think of a regular Cessna plane or even a jet, there's an entire chemical plant on board that transforms like liquid fuel into thrust. Electric, the only moving part is actually the propeller, and everything is stationary, so it makes it a little bit easier. However, we also test a lot. We test every day, many flights every day. And the reason is, in my experience, there's the things that break a system are often unexpected. They're often the confluence of 2 or 3 different weaknesses. And by testing it regularly, we get more and more confidence we can fly people.
But so it is still part of a bigger system too. So I don't know if you're thinking about how the complexity of the national airspace is going to make it very hard to actually collect all the data that we need for the kind of testing you're talking about. How are we going to do this?
Yeah, so one approach I think is hierarchy, so that the lower level controller, even if it may be a learning controller, adapts in a certain way, guarantees certain performance limits to the higher level airspace management system, for example. But it's critical to test that as well.
And going back to Kitty Hawk, when do I get my flying car?
We can take a tour this afternoon. We hope to go into production mid next year.
Okay.
We're still in debugging mode. We build obviously multiple vehicles, only one we've been shown to the public so far. But the nice thing about this is I can teach you to fly in about 2 minutes.
Okay.
As easy to fly as a drone. So I want to change topic a little bit about talking to our students, our prospective students here, now that they listen to the professors. And one of you, start with you, Angela, like, tell us why students should be so excited about this.
I think flying will be a big topic. It is already a really big topic. I mean, we see drones being applied to mining, construction, insurance industries. And for me, a flying car is just another aerial type of vehicle. So what the students learn will really apply to a large range of different industries. And I think, aerial vehicles should be considered by any industry and as a possible to make their, operations more effective.
So you see the really hot and upcoming topic.
Right.
Nick.
Well, the other thing that I think is exciting, specifically about the Udacity offering, is we're working really, really hard to make it as real as possible. Mm-hmm. If you have your own drone, then as you develop the projects through the semester, you can take that code, test it in simulation, and assuming everything works, you could run it on your own drone at home. The first project should be something that you can go, we call it the backyard flyer, because you should be able to go into your backyard and have the thing you did flying around. And even if you don't have your own drone, the hope is that we'll be able to give you an opportunity to test it remotely on a piece of hardware. So that connection to the hardware is core to, I think, this offering. And we're trying to make that as to the extent that we can, a unique experience.
Yeah. So what type of projects will people and students engage in?
Mm-hmm. So one project we are currently building is enabling students to take the data from GPS and IMU and fuse it together to understand where the vehicle is in the space and how it is oriented. And so that's a core algorithm that we need for the vehicles to understand where they are in the environment. Mm-hmm. And then we take this information and the students will build a controller from scratch that keeps the vehicle in the air.
And then you have multi-rotors and fixed wings, right?
Right.
Tell me about that.
So we start with multi-rotors because that is something first that's a bit easier to understand in terms of the physics. And then the students may have multi-rotors at home that they can play with and better understand their physics and program them. And later in the second term, we talk about fixed wing because many flying car concepts include fixed wing dynamics as well.
What's the advantage of fixed wing over rotary wing?
The advantage is efficiency. So the goal is to fly faster with less energy. Mm-hmm. Multi-rotor have the advantage of vertical takeoff and landing, which is important if you want to get off a high-rise building mm-hmm. and fly to the next high-rise building.
Mm-hmm. Yeah. Mm-hmm. And what projects do you have in mind beyond the initial one?
Well, so as I mentioned earlier, what I'm really excited about is getting the students to engage with the challenge of how to make the vehicle smarter. So the second project is path planning. How can the vehicle generate its own flight path through a cluttered urban environment, taking into account the constraints of obstacles and maybe other regulatory constraints and flying a safe and reliable path. But then the issues of autonomy come up in the second semester as well, where we look at issues of mission planning. So there's a lot more to a vehicle doing a task than simply getting from point A to point B. As I said earlier, it's got to be able to get off the ground, it's got to be able to pick a landing location, it's got to be able to sequence, if you're a delivery drone delivering your 3 Amazon packages and 3 to me or whatever, getting between all those in an efficient way, and then planning in the context of other aircraft, fleet management and traffic management, the algorithms for that.
So both of you teach at world-class universities, University of Toronto, MIT, and I'm a recovering Stanford professor, I guess. Tell us, in which way do you think is Udacity different from those institutions?
Yeah, so we actually have 2 graduate courses on unmanned aerial vehicles. The major difference is, I think, the practical aspect. As a professor, we don't have the resources to build such a highly reliable simulator and enable students to kind of write almost ready code that they could use in a startup.
So if you had a magic wand, would you then bring the same practical aspects back to your classroom in Toronto?
That's a good question. We do have projects there as well, practical projects. I do think that Udacity has really a role in preparing students for the job. Yeah. And I think at the university, we want to build the kind of basic knowledge that they can take and then maybe take another Udacity course and then go in a certain industry.
Right.
So I view the Udacity, the Udacity experience is terrific, and preparing to teach this material has definitely changed how I think about the coursework that I prepare at MIT. So there's no question that there's some ideas that I'm planning to bring back to MIT. But fundamentally, I think they serve different roles. Whereas Udacity is communicating specific skills to people in specific ways, I view myself more as a sort of slightly touchy-feely, but maybe more organic producer of people who are going to replace me eventually. And that's just a fundamentally different enterprise than what Udacity is trying to accomplish.
Great. Do you recommend your MIT students to take a look at this class?
Sorry, what was the question?
Will you recommend your MIT students to take a look at our nanodegree?
Oh, yeah, absolutely.
That's
especially
great.
for filling in specific skills that so if a student for whatever reason doesn't have the time or can't fit into their schedule, some issues like planning or estimation, but just want to have the experience of specifically implementing it in an air vehicle context, the Udacity offering should exactly give them that specific experience.
It's great. I'm so delighted that we have such amazing thought leaders and professors here involved as instructors, because I think it's a fantastic time where we can focus on job skills and implementation skills, but we also get a good dose of vision of the field and the theory behind it. I think that's our attempt here. I think if we do a good job, I think students coming out should not be lagging behind, at least in the skill set of building flying vehicles, of what really good graduate students can do at top institutions like Stanford, MIT, and University of Toronto.
And I'm super excited about doing this because, like I say, it's a learning experience for me. How to bring this material together, do it in an online fashion. I think it's just benefits all around.
I'm also really impressed how Udacity builds community between students, but also students, professors, companies. It's really building a community around self-flying.
Nick, how disorganizes Udacity?
How disorganizes Udacity?
Just kidding.
So whatever turbulence we had early on, I firmly believe that I'm now the weakest link in this process. So, it's like watching
Enough for broadcasting.
What? Enough for what?
For broadcasting.
If you watch a jet come off the deck of an aircraft carrier, there's a certain amount of loss of altitude initially, but then you get lift and all is well.
Hopefully.
Hopefully.
So your current graduates, what type of jobs do your current graduates take if they go to industry?
My current graduates basically all work on autonomous systems, flying or driving. Many move to the Silicon Valley or work for startups in the Toronto region.
Do they have a hard time finding a job?
No.
No.
I have no unemployed graduates.
Excellent.
Well, for me, about half my graduates have gone on to academic positions. So
that's impressive.
I've been very lucky to have some great people. The other half have not come to Silicon Valley. A lot of them have stayed in the Boston area with one or two exceptions, but they largely have startups. And they've had the biggest problem they have is beating back the hordes of people who are trying to poach them away from the startups. So I think that the work that we're doing, very fortunate, is very attractive to employers right now.
Yeah, and I think that the nanodegree here, even though it's not as mighty as a PhD from Toronto or MIT, much more focused, will lead to the same effect as we've seen in self-driving cars, where our students get hired long before they even graduate from the nanodegree program, which is kind of amazing.
And I'm also impressed that job announcements I see these days really include explicitly hands-on skills, robotic skills, and I think that's something that Udacity really provides.
And at Kitty Hawk, you must have the same challenge in terms of finding talent and hiring people. What are you looking for?
We have a really hard time finding talent. Our main problem is that the world of hardware and aeronautics is very separate from the world of machine learning and software. And the style of development, the speed of development, the ethics, the concern of safety, as you both mentioned, is just very, very different. And then you get these very crappy machine learning type people that have built Google, and then you get this very careful, boring, and Airbus type people who spent decades building maybe a 777, and you bring them into one room, and it becomes a big fight. And what I love about bringing this together is I think there's truth in both, right? I mentioned it before, we can't build a flying vehicle on an afternoon the way we could maybe do an iPhone app. But at the same time, I don't want to wait 10 years until we've spun the industrial thing and put $500 billion into this to build the first flying car. And that's where I see the possibilities here. And in this intersection, we have a super hard time hiring right now.
Mm-hmm.
Yeah, that's right. If I can also ask, what is your biggest, besides the issues of hiring and culture difference, what's the biggest technical challenge you're faced with right now?
Mm-hmm.
So Kitty Hawk, I think there's really nothing unknown in the sense that the flight dynamics are understood and can be built. The hardware is understood and can be built. The software is understood and can be built. There's no magic that we have to pull. I would say the biggest challenge for us right now continues not to be more like AI and airspace management and making the systems robust using AI and redundant and making them safe, then making the operations safe of multiple vehicles at the same time. And it becomes more and more of an intelligence issue of like how to coordinate, right? If you look at the way airspace is coordinated today with the FAA, if you fly instrument, you get this huge block of sky allocated to your plane for like 15 minutes or so, and then there's no other plane in this block, right? But if you want to really have, say, 10,000 drones in the sky at the same time, you can't do this. You have to have a space this small. And if something happens, like wind blows you or wind shear or whatever, or you have a failure of a component, all of a sudden you have to reconfigure everything. And that's something where we're completely missing solutions today.
One of the things that I'm also really interested in is you have a person in the cabin, and that person is going to want to know what's going on. That interface, like, it can't be, you know, a series of switches and dials, or probably can't even be an app. Do you have a sense of what that interaction is going to look like?
Maybe you're flying people regularly, and it's a lot of fun. What we do right now is we're giving people a really easy interface to use. We have a joystick where you go forward, backward, you can turn on the spot, and you can go up and down. And if you let your hands go, then the machine just stays where it is, which is no aircraft in the world has that capability today, which means my 9-year-old son can learn how to fly in 5 minutes, which is very cool. And that's the confluence of modern, basically cell phone type technology and sensing and computing with this relatively appealing idea of a multi-rotor system. We show people basic things like how full is your battery is the most important one. If you run out of battery, that's not good. Gravity will eventually get you. But we don't quite know yet how to coordinate the airspace, right? So have many of these around. And I think that's it's an open issue where, I mean, the FAA has very openly invited innovation and innovative people. And as we figure that out, I think we're going to build a massive industry in that space that you students can be the first.
So are you going to hiring Udacity self-flying car engineers?
Of course we will. Absolutely. We have hired a lot of Udacity students before here at Udacity. They're among our best engineers and our best course makers. And I see no exception here.
Great.
So I want to ask you a final question, okay?
Okay.
Give us your best prediction, maybe starting with Nick. What's the world going to look like in 50 years from now?
Okay, can we just stop for a second? So, like, do you want a rosy answer, or do you want the apocalyptic?
What is gone? North Korea.
We know Miami's going to be totally underwater.
Maybe just leave this in. Okay, Nick.
Okay. So 50 years from now, what's interesting about that question is that nobody has really ever succeeded at answering that question correctly, ever. So I could say anything, and we know that's not going to happen. Well, I think a couple of things we know are going to be true, which is that communication across the world is going to improve. What I think is also going to happen is that people are going to have devices, whether they're cars or drones or in their homes, that make them much more physically productive than they are right now. So we've had, so if you think about how the world has evolved over the last 150 years, moving long distances is very hard. We got the railroad. All of a sudden, people could travel long distances, and it opened up the West and Canada, and US, and Australia, and other countries. And then we got the ability to move things, to arbitrary locations through the interstate highway infrastructure. And then all of a sudden, we got just-in-time manufacturing. Also, I forgot communication at long distances through the telegraph. And all of a sudden, people could live anywhere and talk to each other on the telephone. And now we can move enormous amounts of information around the globe through the internet and that kind of infrastructure. And I think the next big thing is like action at distance, physical devices that are smart enough to carry out the intent of what people want, but far removed from them. And although that doesn't sound like that this flying car vision fits in there, the flying car is going to benefit from that kind of intelligence. And the world is going to be full of devices that do things for us and interact with the environment in remarkable ways.
That was a great answer. I want to hear your vision too, 50 years from now.
50 years from now. Yeah, 50 years from now, I really think that we will have more physical interaction, like tools that right now we have computing that makes our lives much easier, but we don't have the physical interaction yet. And I think that will come, like automated systems that actually really work in the physical world, and not only in industrial plants, but in our homes. And in terms of the transportation, I really see no reason why transportation should not become much, much more autonomous for people and for goods. The trains, cars, flying cars, I think all of that could be made autonomous, and this way transportation of real physical things becomes much easier.
So I want to invite you for the year 2067 to come over here to Mountain View, and then we're going to watch this tape together. And maybe
You're
you'll fly
sending his Kitty Hawk aircraft to come pick us up.
No,
right?
I'm going to beam you in.
Oh.
Because then we can beam people around. Well, it was fun to make this wonderful round of discussion happening, and I'm so excited that both of you are such great instructors in our nanodegree program. And for you who are watching, if you are interested in becoming a student, enroll or apply, and I guess I see you in class.